wish you all a very happy morning, students. Today we are going to deal with the second exercise of the second chapter, polynomials. Now this exercise is based upon two concepts. First one is if there is any quadratic polynomial of the form ax square plus bx plus c such that alpha and beta are the zeros of this polynomial, then sum of the zeros is equal to minus times coefficient of x by coefficient of x square, and the product of the zeros is equal to constant term by coefficient of x square. So this is the relation between zeros and coefficients of a given quadratic polynomial. Now the question is how to find out the zeros of a given quadratic polynomial. So in standard 9 we have done factorization by splitting the middle term. So by using splitting the middle term, we will reduce this quadratic polynomial as a product of two linear factors. Equating each of the linear factor to 0, we will get the two zeros of the given polynomial. So we can say sum of zeros is equal to minus b by a and product of zeros is equal to c by a. This is the relation between the zeros and the coefficients. The second concept that will be used in this exercise is if alpha and beta are the given zeros, then the required polynomial. So if alpha and beta are zeros of a quadratic polynomial, then we can say that the required polynomial will be equal to x square minus sum of the zeros into x plus product of the zeros. So if the zeros of a quadratic polynomial is known, you can find out the required polynomial. The required polynomial will be x square minus sum of zeros into x plus product of the zeros. So based on this concept, we are going to solve this exercise. So let us take up the questions. We will discuss different types of questions so that it will enable you to solve the rest of the questions. Let us take up the first question. Find the zeros of the quadratic polynomial and verify the relationship between the zeros and the coefficients. So there are two parts of the same question. First of all, we have to find out the zeros of the quadratic polynomial, and after finding out the zeros, we have to verify the relationship between zeros and coefficients. So I am taking up the first question. X square minus 2x minus 8. So this is the first question. So first of all, we need to find out the zeros. We will use concept of splitting the middle term. 4 2s are 8. So the factors of 8 is 4 and 2, and using the difference of the factors, we have to get minus 2. So this can be written as x square minus 4x plus 2x minus 8. If I take x common, x minus 4 plus 2 common, x minus 4. If I take x minus 4 as common, then x plus 2. Therefore, zeros of the polynomial are 4 and minus 2. So we have got the zeros of the polynomial as 4 and minus 2. So this was the first part of the question, where we need to find out the zeros of the given polynomial. Now we have to verify the relationship between the zeros and the coefficients of the polynomial. So we can say let alpha is equal to 4 and beta is equal to minus 2. So alpha plus beta is equal to 4 plus minus 2, that is 2. by 1. That is minus times coefficient of x by coefficient of x square. So we have got the sum of the zeros is equal to minus times coefficient of x by coefficient of x square. Now let us deal with the product of the zeros. Alpha into beta. So 4 into minus 2, that is minus 8. So I can write minus 8 as minus 8 by 1, which is equal to constant term. Which is equal to constant term by coefficient of x square. So here we have shown that the sum of the zeros is equal to minus times coefficient of x by coefficient of x square, and the product of the zeros is equal to constant term by coefficient of x square. Hence it is verified. So we can write hence verified. So in these types of questions, you have to first find out the zeros of the given quadratic polynomial, and after finding out the zeros, you have to verify the relationship between zeros and the coefficients. So I feel in the same manner you will be able to solve the rest of the questions of question number 1. Now let us take up the second question. Find a quadratic polynomial each with the given numbers as the sum and product of the zeros respectively. It means the sum of the zeros and the product of the zeros are given to you, and you have to find out a quadratic polynomial. So let us proceed. We will take the first question of this type. That is question number 2, part 1. Question number 2, part 1. Given zeros, or we will say given sum of zeros is equal to 1 by 4, and product of zeros is equal to minus 1. So we can say required polynomial. Is equal to x square minus sum of zeros into x plus product of zeros. So this is the formula that we are going to use. X square minus sum of zeros into x plus product of zeros. So in this question directly the sum of the zeros is given and the product of the zeros is given. So we will simply substitute the values. X square minus 1 by 4 into x plus minus 1. That is x square minus 1 by 4 into x minus 1 is the required polynomial. You can leave the answer here or you can proceed a step further. We can write 4x square minus x minus 4 whole divided by 4 as the required polynomial, or we can say 4x square minus x minus 4 can be considered as the required polynomial because we are not taking into consideration this constant. So this constant can be removed. You can leave the answer here also, there is no problem, or you can proceed and you can say that this can be the required polynomial. Because in some of the books you will find out the answer is not given in this form, the answer is given in this form. So therefore you have to understand that all these are the quadratic polynomial whose sum of the zeros will be 1 by 4 and the product of the zeros will be minus 1. So in the same manner, in question number 2, you can solve the other questions which are of similar types. They have given you the sum of the zeros and the product of the zeros, and you have to simply write the quadratic equation. So I feel this exercise will be done by you on your own. Thank you.